No one knows what it's like to be the bad man, to be the sad man behind blue eyes. No one knows.
Okay, 6.2 is on linear inequalities. And if you understood the first section, first video in this chapter, which was on graphing lines, you're going to be okay with this. So, first of all, what's a linear inequality? Well, what you graphed before were linear equalities. So you graph things like y equals 2x plus 3, right? That's in slope-intercept form. Or you graph things like 2x plus 5y equals 10. That's in standard form. So those are linear equalities that you graphed before, and they're called equalities because one side is equal to the other. Today what you're going to learn how to graph is linear inequalities. So that would be things like y is greater than 2x plus 3, or 2x plus 5y is less than 10, or y is greater than or equal to 2x plus 3, or 2x plus 5y is less than or equal to 10. Okay, so there's four types of inequalities: greater than, less than, greater than or equal to, less than or equal to, and you're going to learn how to graph those. The good news is the most difficult part probably you already know, and that's the first step, because the first step is to actually graph the related linear equality. So if you were asked to graph y is greater than 2x plus 3, the first thing you would actually do is to graph y equals 2x plus 3. You do that first. Okay, the second step is you would decide whether to draw a solid line or a dotted line. So, when you draw your line, I said you started by drawing y equals 2x plus 3. You're going to set up all the points, and then before you join them, you're going to say to yourself, should I be drawing a solid line or a dotted line? And you will draw a solid line if you need to include the points on the line, and you draw a dotted line if you want to exclude the points on the line. In other words, it doesn't include the points on the line, and I'll explain that in a second. And then the third thing you do is you shade the half plane. Use a test point and you shade half plane. So I'll explain that, but there's the steps just so you have them written down. So the first thing we're going to do is we're going to graph 2x plus 3y is less than or equal to 6. And the first step up to here says that you need to graph the related linear equality to start. So what we're going to graph first is, I wouldn't expect you to write this down. Obviously you could do this without writing it down, but I'll write it down. 2x plus 3y equals 6. That's the first thing we're going to graph. Now, how are we going to graph that? Well, one way you could do is you could change this into slope-intercept form by moving the 2x over and dividing everything by 3. But the way you'd probably do this, since it's in standard form, is you'd probably get your x and y intercepts. Whoa, it's on an angle for some reason. So if I'm looking for my x-intercept, what I know about every point that's on the x-axis, it has a y value of 0. And if I put 0 in there, that's 3 times 0, so it's gone. All I have to ask myself is 2 times what equals 6? 2 times 3 equals 6. So that point is right here. If I'm looking for my y-intercept, so that's where it crosses the y-axis, every point on the y-axis has an x value of 0. So 2 times 0 is 0. 3 times what equals 6? 2. There you go. We like to have more than 2 points, but 2 points is enough. We could now draw our line. But wait, don't draw the line yet. Now we have to go to step 2. We have to decide whether to draw a solid line or a dotted line. So I'm just going to draw this first to talk about it. I'm going to draw that it's solid. Okay, there it is. So why do we draw this solid line? Because these 2 points are only 2 of many, 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 many points that satisfy this equation right here, right? These points work when you plug them in. But those aren't the only 2 points that work. There's actually an infinite number of points that work. Every single point that's on this line here, even the ones in the middle of nowhere, non-pretty points, every single one of them works. So let me pick just another point here. How about this point, right? Well, let's pick this one. This point here is negative 6, 6. Negative 6, 6. So if I plug negative 6, 6 in here, it should work. If I put negative 6 in for the x and 6 in for the y, it should work. So let's see. 2 times negative 6 is negative 12. I don't know why I did it here. I'm squishing it. 3 times 6 is 18. and it should equal 6. Does negative 12 plus 18 equal 6? It does. Absolutely. Every single point on this line works. All the points that aren't on that line don't work. All right. Now, if the equation was 2x plus 3y, I'm just going to write it over here. What if it said 2x plus 3y is less than 6? If it only said that, 2x plus 3y is less than 6, would that point I picked here, negative 6, 6, would that be a good point to pick? Well, I know this is a bit redundant, but let me do it again. Negative 6, 6. So I'd put negative 6 in here, and I'd put 6 in here, and I'm asking whether this is true. So negative 12 plus 18, and then negative 12 plus 18 is positive 6. So, is this true or not? 6 is less than 6. Is that true? No, it's not true. Okay. So, if you have a less than or equal to, or a greater than or equal to, then you're going to use a solid line, because that shows that the points on the line work because they are actually equal to what you're interested in. But if it's just a less than or a greater than sign, you're not going to use a solid line. You're going to use a dotted line, or a broken line if you want. You could also do it like a broken line like this. Either way you want, dots or a broken line. And the reason for that is you're showing that the points that lie exactly on the line actually don't satisfy the inequality. So in this case, if we're looking back at this inequality, should we have a solid or dotted line? We should have a solid line, because the points on the actual line work, right? If whatever point we put from this line we put in here, it makes it equal to 6, and we're okay with it being equal to 6. So a solid line. Okay, blah blah blah. That was way too long of an explanation. So now the last step is to shade the half plane. So you're going to find with all these questions, you're not just interested in when it's equal to, you're also interested in when it's less than, or sometimes when it's greater than. So what that means is there's points that aren't on the line that also work. And it turns out it's going to be either all the points up here work, every single one of them, or it's going to be all the points down here work, every single one of them. That's all you have to do is figure out which side of the line works. That's the half plane I'm talking about. So how are you going to figure it out? Well, what I do is I use a test point. I just try any point I want, as long as it's not on the line. You can't try one of those because we already know what happens there. It makes it equal to. You have to try one of the points that's not on the line. What would be the easiest point to try that's not on the line? How about that point, the origin, 0, 0. So I'm going to write test point, 0, 0. That's the point I'm going to try. So let's try it in the original question now. 2 times 0 plus 3 times 0 is less than or equal to 6. 2 times 0 is 0, 3 times 0 is 0 is less than or equal to 6. Is this true that 0 is less than or equal to 6? Yeah, that's absolutely true. 0 is less than 6. So this point worked, and if this point worked, it means every single point over here works. So the way that I shade it, because I don't like to fill it, sit here coloring it for 10 minutes, is I do this. That means that every single point over here works, and it goes on forever, right? I suppose I could even draw arrows, but I won't. I'll just draw it like this, and it goes on forever. That means that everything point on this side doesn't work. If you don't believe me, let's pick a point. How about this one? This is 8, 1. Just randomly picked a point. So 2 times the x value, which is 8, plus 3 times the y value, which is 1, is less than or equal to 6. 16 plus 3 is less than or equal to 6. 19 is less than or equal to 6. Is that true? No, that's not true. So you would not shade this side because it didn't work. That's it. That's how you do these. Let's do another one way faster. So the first thing we're going to do for this one is we're not going to graph this. We're going to graph this. Whoops, negative 1/3 x plus 5. And we love graphing this. This is in slope-intercept form. Here's our slope. Here is our y-intercept. So it has a y-intercept of 5. Go up to 5. Has a slope of negative 1 over 3. That means rise negative 1, go down 1, and over 3, run 3. 1, 2, 3. I'll do that a couple times. 1, 2, 3. Okay, it's time to draw a line. Should I draw a solid line or a dotted line? Well, in this case, remember, if I draw a line, all those points make it equal, make the two sides equal. Are we interested in when they're equal? No, we're not. We're only interested in when it's greater than. So you don't want to draw a solid line because the points on the line actually don't work. They make the two sides equal, but we want this side to be greater than that side. So you need to draw a dotted line. Okay, I'll do that now. Last step is to figure out which side to shade. So I'll use a test point, and my test point I'll try is, what would be a good one? How about the origin? You don't have to. You can use any point you want as long as it's not on that line. But personally, I always use the origin, unless what? When's the only time you can't? If this line was to go right through the origin, you wouldn't be able to use it. But I always use the origin otherwise. So I have y, which is 0, is greater than negative 1/3 times 0 is just 0 plus 5. So that means 0 is greater than 5. Is that true? No, that's not true. So this point, the origin, does not work, which means every point on this side does not work, which means all the points on the other side up here do work. So this is your answer. Now, one thing you're going to notice is if it's written in slope-intercept form, y equals mx plus b, it's really easy to know what side to shade, because if it says greater than, it just means above it, and if it says less than, it just means below it. Personally, I don't know why I always use a test point, it just makes me more comfortable, but a lot of students notice this, that if it's in slope-intercept form, you can always just take the top of it if it's greater than, the bottom of it if it's less than. Okay, now we're moving on. We're doing a system of linear inequalities. So remember, a system of linear inequalities is when you have more than one equation at the same time, or in this case, more than one inequality at the same time. We did this before. So for example, in a system of linear equations, say you had one equation which was y equals 2x, and you got that looking something like this. I'm just doing this very rough, obviously. And you had another one which was x equals 2, which looks like this. And we wanted to know what the solution is to both of to this system. We want to know where's the point that works for both of them. And it's where they cross, right? The system is solved by the point 2, 4. If you plug 2, 4 into this one, it works. 2 times 2 is 4, and that's exactly what we'd have there. And if you plug an x into here, the 2 equals 2, that's true as well. That's a linear a system of linear equations. Now we're doing a system of linear inequalities. So what's the difference? The difference is you're not going to have one point that works. You're going to have a whole bunch of points that work, because you're going to see where the half planes intersect. You solve this the same way though. You're going to graph both of these inequalities and see where the common region is. So let's start by graphing the top one. We have 3x plus 2y is greater than negative 6. We'll graph 3x plus 2y equals negative 6. This is in standard form, so I like to use my intercepts. To get the y-intercept, I put 0 in for the x. So 3 times 0 is 0. 2 times what equals negative 6? Negative 3. So that's this point. To get the x-intercept, put 0 into the y. 2 times 0 is 0, so that's gone. 3 times what equals negative 6? Negative 2. So that's this point. Okay, I'm going to join those together. I'm going to join them with a solid line or dotted line. So look at the sign. It's only greater than, not greater than or equal. So what kind of line should I have? Dotted. Okay, now we would do our shading, but this can get really messy with the shading. For the test point, if I put 0, 0 in there, so test. If I put 0, 0 in here, I get 0, 3 times 0 is 0, plus 2 times 0 is 0, is greater than negative 6. Is this true that 0 is greater than negative 6? Yes, it is. So that means, in this case, that the origin worked, which means all the points on this side work. So what I'm going to do is I'm just going to put some check marks along here. I don't know why, I've never done it this way. I'm just going to do this for a second. If you want, just don't shade it at all, and we'll come back to it in a second. Okay, let's do the second one here. The second inequality is y is less than or equal to x minus 4, but I'm going to write it as y equals x minus 4. Well, this is great because this is in slope-intercept form. What's the y-intercept? Negative 4. What's the slope? What's the number right here? The number is 1, and we like it to be a fraction, so 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1. It just makes a 45-degree angle here. And what kind of line should I draw? Solid or dotted? Well, if you look, it's less than or equal to, so it should be a solid line. Okay, there's that one. Now, we have to figure out what side of that to shade. So let's use our test point again. So we're using it up in the original here. If I use the test point of 0, 0, I get, so test, 0 is less than or equal to 0 take away 4, which is 0 is less than negative 4. Is that true that 0 is less than negative 4? No, it's not. So this time, where you would want to shade is not on this side, because that includes the origin. You'd want to shade on the other side, so you'd want to shade down here. Okay, do you see there's 4 sections here? There's one section up here, here I guess, right? There's a second set. I mean, there's no particular number to them, but you can just see there's 4 sections here. Okay, those are the 4 sections. So I'm going to take those away. What's the section that works for both of them? Where's the section that has multiple check marks in it? This is the section here. So here's where you'd want to shade, right here. Okay, that's the section that works. I don't know about doing these check marks. I don't really know why I did that. But you have to figure out what's the section that has double shading, kind of. This one, this section up here, the V up here, only would satisfy the first inequality. The one down here would satisfy the second inequality. The yellow one satisfies both inequalities, which is what we're interested in. What about this one way out here? Doesn't satisfy either of the inequalities. So do it whatever way you want. Sometimes people do shading and then erase the wrong shading later. Sometimes people double shade with a different color. You could try this check mark technique. I'm not really a fan of it. I don't know why I did that. Okay, that's a system of linear inequalities. Last thing, here's a system of linear inequalities, and we have to write down what the equations are of these lines. So there's 3 lines here, and we've got to get the equation of each one. Let's start with this green one. So this is a vertical line. Do you remember what's true about every vertical line? If not, ask yourself this question. Every single one of these points has the same x value or y value? X value. What's the x value? -4. So it's x is equal to -4. But wait a minute, we're talking about inequalities here. We have this shading to the right of it. So that means we're not only, and it's a solid line, so we like the equals part, but we're also interested in all the points that are bigger than -4. So it actually should be x is greater than or equal to -4. Pretty messy, but hopefully you get that. Okay, let's look at the red line. Similarly, it's a horizontal line, so if you don't remember what that means, think of what all these points have in common. They all have the same y value. What's the y value of all those points? -1. So y is equal to -1, but I won't write that yet, because all the other points, all the part we've shaded here, they're all bigger than -1, so its y is greater than -1. Should it also be equal to? Yes, it should, because it's a solid line. Okay, last one, a little bit more difficult here. The dotted line here. So let's put this in slope-intercept form. I think that'll be the easiest way. So we want it in y equals mx plus b. What is the y-intercept? Easy, right there, it's 3. So we're going to put a 3 in there. What's the slope? That's a 3. What's the slope? Well, pick some pretty points. I'm going to pick this one and this one. So it looks like it has a rise of 2 and a run of 3. So the slope is 2 over 3. But be careful, what kind of slope is it if it's like this? Negative. So now we can write this in slope-intercept form. It's y equals, but I'm not going to write that yet, -2/3 x plus 3. So should it be greater than, less than, greater than or equal to, or less than or equal to? Well, we know it can't be greater than or equal, can't be less than or equal to, because it's broken. It's either this or it's this. How are we going to decide? Well, first of all, it is in slope-intercept form, so you could use that little hint I gave you about, since it's kind of below the line, it's obviously going to be like this. But if you don't like that, you could also use a test point. Let's say I'm going to try the test point of 0, 0 and see if it works. Okay, so if we put 0, 0 in here, you get 0 is less than -2/3 times x, or times 0 is 0 plus 3, 0 is less than 3. Is this true? Yes, it's true. So having the sign this way makes sense. If you'd plugged in 0, 0 and you got something like 10 is less than 3, you'd see that, whoops, the sign's facing the other way, I have to flip the sign around. But this is correct, and this entire batch of inequalities here is what you're looking for this question. Okay, that's it. All done. Have a good day.
But my dreams, they aren't as empty as my conscience seems to be.